Hi everyone, this is Amrit Neupane. I'm here with my group members Ayush Shakya, Ayush Shah, and Barshana Shrestha to propose a design for the company and also for our assignment BN321 assignment 2. So according to the requirements, we've got two buildings on each side. So each building represents one site for the company. The one on right hand side is Sydney with 7 departments, whereas the one on the left hand side we've got our Darwin building with 5 departments. So this is our main topology. So this is going to be the ISP router that connects to two routers on each side for each sections, as in like Sydney and Darwin. So the routers are in turn connected with a server switch that is connected to a couple of BTP client switches. So the switches provide internet access to the workstation in for the different departments. So my part for this presentation is mainly going to be the DSCP. So let's jump onto DSCP. So we've got our two DSCP servers over here, one for each side. So let's have a look at the services. So let's jump into DSCP. So as you can see, this network, so it does a gateway of 4.1. We need to assign IP to the router, the default gateway port, and the server manually, so that we could access the network. So we've got a default gateway for 4.1 for the router, and say let's got an IP of 4.3. Good. So on whereas on the other side, we've got our DSCP pool setup. Same thing, 4.2 gateway, and this also has its own IP of 4.4. So it's basically 4.1, 4.2, 0.3, and 4.4 for the routers and switches. So everything else is going to be assigned by DSCP by itself. So let's try and pick one PC. On Sydney side, let's say this department okay. Let's send it to static and DSCP. It's requesting IP address. Meanwhile, we can jump onto the other side and access its IP. So this should be done by now, by this time. Now, still requesting IP address. And this one is also still requesting. I don't know what's taking so long, but should be fine so take a couple more seconds. I think this one's done. Yeah. So this one's done 4.6, and with the gateway 4.2. With the gateway 4.2, and this one should be done by now. Yeah, 4.9 with the gateway 4.1. Yeah, perfect. So let's try pinging each other. So as we can see, the server is giving IP addresses to the workstations correctly. Now let's try pinging it. So for example, we've got this PC. It can communicate within the network as well. So let me clear this out first. So this PC can communicate within the network as well, within the Darwin network, successful, and also within different sites, as in like Darwin to Sydney. So it was successful. Yes. And let's try it on the other side. So one department to other department, successful, perfect. And let's try from this department, this PC to this one. Say yes, successful. So yes, that's pretty much it about DSCP. So for more further configuration, I'd like to pass my slides to my team members.
I'm going to present about the VTP client and server switch. So basically, reason for setting the VTP is because it provides the easier method for maintaining the consistent VLAN configuration throughout the switch network. And in the scenario given, we need like almost 12 VLAN to set up. So doing VTP server and VTP client, it helps us to reduce time. And let us see how the VTP client and server switch work. So the multi-layer switch, I have set up it as a server switch, As you can see here, the BTP operating mode is server. Uh, uh, its domain name is set up as AAA, and its capable version is 122. So it's the main switch, considered as the main switch, and whatever we set the VLAN here, we don't have to set up the same VLAN in the client switch here. So let's see the client switch. The VTP mode, operating mode is client, the same domain name here. So for example, let's say go through config and VLAN database. So we have finance manager, IT research and marketing, like this many VLAN here. And as setting VTP server and client, after setting up the VTP here, we don't have to individually uh, set the VTP in each switches here. It will automatically set up for the client switch as well. Let me show you the VLAN database here as well. So yes, there you go. Finance manager, IT reception, all that thing. So whatever you set up in the main or say server switch, it will automatically adopted by the client switch. That's the point of VTP. And for the next demonstration, I would like to pass it to my friend. Thank you.
Now I'll be explaining about the VLAN configurations that we have performed in our network diagram. So what we have created VLAN here is to connect the computers and devices of each department virtually as if they are in a same LAN. We have used it to improve the network security and also to provide the network flexibility along with reduce in IT cost. Now I will be quickly sharing my screen to show the configurations that we have performed in our network diagram. As I've already written down the commands here, I'm just going to quickly show how we have performed it. So to create the VLAN, we have used the following commands. That is, for example, to create VLAN 40, we have used VLAN, we have written down VLAN 40 and its name as manager. Similarly, to create VLAN 50, we have written down the name VLAN 50 with its name IT. In the same way, we have also done trunking of the VLAN here. For that, we have used the following command, that is int range fa 0/126, and the command switch port mode trunk no shut. Here we have only taken the range 1 to 6 as these are the switch ports that only interconnects the switches. In the same way, by doing this so VLAN in this multi-layer switch, we're able to view the VLANs that are created in the whole network diagram. And the VLANs are 10, 20, 30, 40, 50, 60, 70 with its respective name. Finance, HR, public manager, IT reception, and marketing with its status active. So this was all about the VLAN configurations that we have in our network diagram. Thank you.
Hello, thank you for passing it to me. I'm Ayush Shakya here to present on BN321 Advanced Network Design Assignment 2, and I'll be specifically discussing on network routing protocol that we'll be using in this network design. As per the assignment requirements, and as you can see in this network design, there are two locations, Darwin and Sydney, and we'll be using three routers for that. For exchange of information in between the routers, we must use routing protocols, and for that purpose, we'll be using routing information protocol, that's RIP protocol, for exchange of information in between the routers. When we ping between one router to other router, it's always successful. This is only possible just because of use of routing protocols. Using the RIP protocols in these routers, I'm just gonna quickly demonstrate how do we use that. So when you go into the router and enable the router, so running config, Here we can see how we use RIP protocol. Here it is, router RIP version 2, and we've added the network addresses, the one where we'll be exchanging the information within each other. One network is 192 network, that's our Darwin network, whereas thin network, it's the ISP network. Similarly, when we see the router that's located in Sydney, it shows the same thing. Uh, s- First we enable the router, then we show running config. Uh, so here as well, we've used the RIP protocol and added the network addresses for exchange of information in between the routers. So when we try to ping between the PCs, the pinging is always successful just because of use of routing protocols. So that's it from our side. And yep, thank you very much for listening.